AI is helping developers write code faster than ever before. That's great for productivity, but it also creates a new challenge. Open source code can enter a code base through autonomous agents, through AI-generated suggestions, or through modified snippets that never appear in a package manifest. Simple managed dependency analysis has no visibility into that world. This increased coding velocity with decreased code provenance visibility means more risk being discovered downstream when it's more costly to mitigate, thereby negating the productivity gains of AI-accelerated software engineering. Agentic SCA by FossID brings software composition analysis directly into the developer IDE and their AI coding agent, helping teams identify compliance and security risks while code is still being written. The result? You gain the advantages of AI without increasing risk and effort later in your software delivery process. In this demo, we'll show you how Agentic SCA by FossID works within the VS Code IDE. Once the FossID extension is installed, developers have immediate visibility into the policies that govern their project. Here we can see a license policy that treats strong copyleft and weak copyleft licenses as errors, while business source license and server-side public license components generate warnings. These policies can be configured directly inside the extension, or they can be managed centrally through FossID Workbench and distributed through the repository using a FossID policy file. That means compliance teams define the rules once, and developers receive consistent guidance wherever they work. Now, let's see what happens when code is introduced that violates policy. Here we have an open source component licensed under GPL version 3. We'll take a small code fragment and add it to our project. In practice, this could happen in several ways. A developer might copy code from an online source, or an AI coding assistant might generate code that resembles that of an open source project. Either way, the result is the same. New code enters the repository. As soon as the code is introduced, FossID analyzes it and identifies the match. The FossID for VS Code extension immediately reports that a prohibited strong copyleft component has been detected. No separate scan, no waiting for a compliance review later, and switching context again to fix it. The feedback appears while the developer is still working in the file. Developers can review additional details, including information about the identified component and the source of the match. This helps them understand not only that there is a problem, but why. License policy violations are just one example. FossID can detect a broad range of software supply chain risks as code is added or modified. Let's look at some of the other detection capabilities available in the extension. First, modified license detection. This is a capability that's often overlooked. License text isn't supposed to change, but modifications can occur through manual edits, code refactoring, or other unexpected changes. Here we're taking a standard BSD license and introducing an additional clause. I'm going to add what I'll call my Dr. Evil clause. You have to give me, the author, $1 million. FossID doesn't just recognize licenses. It analyzes the actual license text and compares it to the canonical version. The extension identifies that the license has been modified and highlights exactly what changed. That's important because even small changes to license language can have significant legal implications. Next, let's introduce a new dependency. In this example, we're adding a version of jQuery that contains known vulnerabilities. FossID continuously correlates dependencies against vulnerability intelligence. Once the dependency is introduced, the extension automatically evaluates it. The result is immediate visibility into the risk. The developer can see that a vulnerable dependency has been added and review additional details directly inside the editor. This allows issues to be addressed before they move downstream into testing, security, review, or release preparation. In addition to license violations and vulnerable dependencies, FossID can also identify vulnerable code snippets. This is particularly important in the AI era. Other scanners typically identify vulnerabilities based on component names and versions being clearly identified. FossID can also identify vulnerabilities at the code level by matching known vulnerable code fragments for which exists a patch. What you've seen here is more than another VS Code extension. It's an example of Agentic SCA in practice. Compliance and security checks happen at the moment code is created or modified, while developers still have context and can act immediately. Instead of discovering issues weeks or months later during audits, pull requests, or release reviews, teams can address them when they are easiest to fix. Developers increase productivity. Compliance teams reduce risk. That's software composition analysis for the AI era. That's Agentic SCA by FossID. Learn more at fossid.com/agentic.